Good morning, students. Today we are going to discuss the question: what are the binary trees and what are the advantages of a binary tree? The question: what are the binary trees and what are the advantages of a binary tree? So actually, binary tree is a non-linear data structure. Binary tree is a non-linear data structure in which each node has a maximum of two child nodes are there. So in this binary tree, each and every node have contains maximum of only two child nodes are there. Okay, so exceeded of a two child nodes cannot supported in a binary tree. Okay, so in each and every binary tree that can be contains maximum of two child nodes. So of course one child node also that can be supported in a binary tree. A tree that have contains either one or two child nodes are there, and the tree connections can be called as a branches. Actually tree connections are called as a branches are there. So diagrammatically binary tree representation like this one. So this is considered as a binary tree. Okay, this is considered as a binary tree. So in this binary tree, each and every one is called as a node. Okay, each and every one is called as a node. One node connected to the another node, one node connected to the another node. So in the hierarchy formats, we need to connections in between the multiple nodes. So that is called as a binary tree. Okay, so in this connections is called as a branches. In this connections is called as a branches. For example, 40 connected to 35, 30 connected to 22, 22 connected to 28, which is called as a branches. Okay, right. The next point: trees are used to represent data in hierarchical format. Okay, the trees are used to represent the data. These are the data: 40, 35, 56, 22, 48, 28, 65. So these are called as a data. This data we need to arrange in the hierarchical format. Okay, in hierarchical format. So that should be supported into the binary tree. So that can be arranging that elements into the trees format. Binary tree is on which each node has a maximum of two child nodes are there. Just now told you what is that? Each and every node have contains maximum only two child nodes are there. Here observe the 40. This is one of the node. This node have contains maximum how many child nodes are there? Only two child nodes are there. That is 35 and 56. Okay. 56 have contains only one child node. Yes, that can be supported within the binary tree. Either one or two or empty, whatever thing that can be supported. But maximum each and every node have contains only two child nodes are there. The next, the order of a binary tree is 2. So that's why we are calling a order of a binary tree. Okay, maybe asking the Viva question. Okay, order of a binary tree is 2 because of each and every node maximum have contains only two child nodes are there. That's why order of binary tree is 2. The next, binary tree does not allows duplicate values. Here observe, is there any happen the duplicate values is there in this binary tree? No, because of, so in this binary tree does not allows duplicate values. That is important point. Okay, duplicate, each and every binary tree does not supporting duplicate values. Okay, that is important point. The next, while constructing a binary tree, okay, while constructing a binary tree, if an element is less than the value of its parent node, so actually how to arranging these elements? So for example we have taken, these are the some elements are there, binary tree elements. What are the elements? 40, 56, 35, 48, 22, 65, 28. Okay, these elements are inside, these elements are presented in the shuffle format. Okay, actually in the randomly that can be arranged, but in the binary tree we need to arranging in orderly. How can it will be arranging the elements into a binary tree? Okay, that is the step. What is that? Actually if an element is less than the value of its parent node, okay, what are the choosing element to compare with the parent node? If that node is a lesser value of a parent node, automatically it should be placed on left side. Okay, otherwise the greatest element comparing with the parent node, automatically that should be arranged into the right side. Such way we are going to arranging the elements into a binary tree. Okay, so based on this, for example, how to arranging these elements above these elements, it should be arranged into the binary tree format. Okay, so first what are the element presented here? 40. Just we need to inserted 40 element into the node. Okay, so this is called as a parent node. This is called as a parent node. Okay, right. So the next we have chosen what is it? 56. 56 is always comparing with the parent node. Okay, 56 is always comparing with the parent node. So is this a greater value or lesser value? Greater value of the parent. So that's why we need to go for to the right side. We need inserting an element. Okay, 56 comparing with the parent node, that is a greater value. That's why we need to inserting an element into the right side position. The right side node we need to inserting 56. Okay, fine. The next 35 elements. 35 is comparing with the parent node. So 35 is the lesser values of a parent node. Okay, so that's why we need to arranging that element into the left side. Okay, 35. Such way we need to arranging the remaining elements. What is that? 48. So 48 first comparing with the 48 first compare it with the parent node. Okay, each and every node first we need to compare it with the parent node. After that subchild nodes. Okay, 48 is a greater values. Okay, 48 is a greater values comparing with the what is that? 40. Okay, automatically what is that? It should be go for the right side. It should be go for right side. So this is 56. Actually next here to delete 56 here already presented 56. Now once again this 48 comparing with the 56, is this a lesser value or greater value? Yes, comparing with the 56 is the lesser value. That's why we need to arranging that element to the left side. Okay, like this one. Left side we need to arranging that element. So we need to give the connection like this one. Okay, this is the next element 22. Okay, 22 is comparing with the parent node. Is a lesser value or greater value? Lesser value. Okay, so that's why we need to go for the left side. Left side already existed element. Once again compare with this existed element 35. 22 compare with the 35 is a lesser or greater value? Lesser value. Once again go to the left side and that should be inserted in this location. Okay, 22. The next we have to choose 65. 65 compare with the parent node, which is a greater value. Okay, so that's why go to the right side. Already existed 56 element. Now once again compare with the 56. So is this greater or lesser value? Yes, comparing with the 56 is the greater value 65. That's why go to the right side and inserted that location. The finally 28. 28 comparing with the parent node 40 is the lesser value. So that's why go to the left side and once again compare with the existed element 35 is the lesser value of 35. Once again go to the left side. Already existed 22. Comparing with the 22, 28 is a greater value. That's why I go to the right side and inserted this location. In this way we are going to arranging the binary tree elements are there. Okay, so actually the searching in a binary tree becomes a very faster. Okay, actually binary tree it was introduced in the purpose of to searching elements so very faster. That is one of the advantages there. And binary tree provides 6 traversals are there. Actually binary tree provides 6 traversals in order, pre-order, post-order. Okay, in order, pre-order, post-order. Okay, so in that way we need to arranging the elements and maximum and minimum elements can be directly picked up. So from the binary tree that can be possible to pick up an element either minimum and maximum elements that can be supported in a binary tree. So these are the some information regarding a binary tree concept. This is an important maybe asking in the final examination. Okay, just understand. So thank you.